All right, we're looking at fraction busters here. We're going to formalize what you saw yesterday that you could use to simplify an equation that has some fractions in it. And there's a reason why we're doing this, because it's going to go beyond just simple fractions like this, and we're going to start to combine this with what we've learned so far about simplifying rational expressions. All right, so let's start off here. I'll show you 34, and then you can go ahead and you can try 35 on your own, see how you do. All right, step number 1. First thing we want to do is identify the least common multiple. We noticed that when we multiplied by the least common multiple, the LCM, yesterday, it eliminated all of our fractions. All right, now when we talk about the least common multiple, I'm saying the least common multiple of the denominators. In this case, 3 and 2. Well, I start with my biggest one, and I just list out those until I find one that the other number goes into. In this case, the first one's 6. 2 goes into 6, because if I were to list out the multiples of 2, we see that 2, 4, 6 is the least common multiple. That means I'm going to multiply everything here by 6. That's step number 1, identify that LCM. Step number 2, now that I've identified it, let's go ahead and let's multiply that by every single term. We have to multiply everything by 6. That's the multiplicative property of equality. What I multiply one side by, I have to do it to the other side. And I have to do it to everything on that side. You have to multiply every term by that least common multiple to keep things equal. Well, once we do that, we can simplify by canceling out our denominators. 3 goes into 6 because they're division and multiplication, they're opposite, they cancel. 3 goes into 6 twice, leaving 2 times 5x, which is 10x. 2 goes into 6 3 times, leaving 3 times 15, which is a positive 45. Equals, on the other side, 2 goes into 6 3 times, leaving me 3 times 5, which is 15. At this point, I now have an equation with no fractions, and I can solve that equation, which you should be pretty good at by now. Move your 45 to the other side and divide by 10. And we see here x is -3. That's what makes this equation true. You try it now. Take a look at 35a, pause the video, solve it yourself. All right, now that you're coming back to check your answer, I see that we can go through this. We've got the LCN, but this time we've got 6, 4, and 3 as our denominators. Let's look at 6. 6 is 6, 12. Oh, I could stop right there. 4 goes into 12, and 3 goes into 12. That's my least common multiple. Just to show you how I know that, 4, 8, 12. There we go. And 3, 6, 9, 12. There it is right there. Least common multiple. So let's multiply everything by 12. When I do that, 4 goes into 12 3 times, leaving 3 times x, which is 3x. Here, be careful on the second one. Watch what happens. 6 goes into 12 twice, leaving 2 times x, but it's a minus, so it's really a -2 times x. You got to be careful of that negative right there. All right? Equals, on this other side over here, I've got 3 goes into 12 4 times. 4 times 2 is 8. Simplify that equation. It's easy from here on out. X equals 8. All right, good. Try another one. Try B now. Try it on your own. All right, coming back in now. You've unpaused the video. You've done this one already. At this point, you should see that there's only one denominator. So there's no need to look for a least common multiple. I know what I need to multiply by is x, and I have to do that to everything. All right, in this case, x cancels out with x, leaving 5. But here I get 2x times x, which is 2x squared. And here I get 3 times x, which is 3x. Now all of a sudden I have a different type of equation. Something we learned in Chapter 8. This is a quadratic. I've got to solve it in the way I solve quadratics, which is to get it in standard form. I'm going to move my x squared and my 5 over to the other side. The reason I'm doing that is because I want to get it equal to 0, but I also wanted to have a positive x squared term. Because when factoring, I know it's a lot easier to factor with that positive x squared. Notice there's no GCF here, so I can't pull out a GCF, and there's no special case. I'm just going to my diamond problem and generic rectangle here. I see that it's going to be 5 and -2. If you're struggling with factoring here, all right, if you're struggling with factoring, go back to my other videos, watch my videos on that, make sure that you're pretty good on factoring. You will need it a lot moving forward from here on out. All right, so I now find that 0 is equal to 2x plus 5 times x minus 1. Therefore, the zero product property says if 2x plus 5 equals 0, it will make my equation true, or if x minus 1 equals 0, it will make my equation true. Well, I know that therefore x could equal the opposite of 2x plus 5, which would be negative 5 minus 5, divide by 2. All right? And I know that x is the opposite of minus 1, therefore x could be positive 1. These are the two values that make my equation true. But there's something unique in this problem that I have to do. And it all comes back to this right here. I had a variable in my denominator to begin with. So I have to consider the fact that when we deal with a rational expression, when I've got that variable in my denominator, I have to identify the values that x is not allowed to be. In this case, because an x is in the denominator, we can't have 0 in the denominator, x cannot equal 0 here. Well, is the solution where x is equal to, is that 0? No. X is equal to negative 5 halves and 1 here. Neither of those are 0, so we're good. But we do have to check that because if one of those values was 0, then that value would not be a solution to this equation. All right, so we do have to watch out for that when we've got variables in our denominator. We saw that. We're dealing with simplifying rational expressions, and it's going to continue here. Take a look at the next one. Try and do this one on your own. Pause the video. All right, now, if you're picking it back up again, I know I'm looking for a least common multiple between 7 and 3. I'm going to just find my multiples of my largest number here and see which is the first number. There it is, that 3 goes into, 21. So 21 is my least common multiple. All right, most of you are probably able to do that, but maybe you get stuck here. Take a look. 3 goes into 21 7 times, but I've got 7 times the group, negative 2x plus 1. That means I have to do 7 times negative 2x and 7 times 1, giving me a negative 14x plus 7. If you got stuck there, pause it and try and fix your work now and try and do this next part before I show it to you. All right, if you've tried it now, check to see how you did. 7 goes into 21 3 times. But be careful. This is really a group of x plus 3. This 3, I'm going to put it out here for a moment so that you can see that it's really a negative. We got to watch out for that negative right here because it was minus the entire group. So I really have a negative 3 being distributed in there, giving me a negative 3x and a negative 9 equals, on the other side, 8 times 21 is 168. Now we can simplify and combine our like terms and get x completely alone. And I find that x equals negative 10 in this case. I didn't have any variables in my denominator to begin with, so no excluded values of x that I got to look for. Take a look at the next one. Pause the video now, try D, see how you do. All right, picking it back up again. We saw 2 turns ago in B, we saw that not only could the least common multiple be a number, but it could be a variable. All right, and here we see that the least common multiple can actually be a group. In this case here, the group is x minus 2. So I'm going to multiply everything by x minus 2 because when I do that, these groups in my denominator are going to end up canceling completely. All right, leaving me with x plus 3. But here I've got 2 times this group, so it's going to be 2x minus 4. All right, and over here I have x plus 5. Now let's combine our like terms and let's go ahead and simplify this. I'm actually going to do something unique here. I'm just going to subtract x from each side to get rid of those 2 x's rather than combining my like terms. And I'm also going to see something here. I'm going to subtract 3 and add 4. All right, subtract 3 and add 4 to just move all those over to that side. When I do that, these cancel, these cancel, these cancel. I have 2x equals over here. These cancel. I've got 4 plus 5 is 9, minus 3 is 6. And I can divide by 2 to find that x equals 3. Now double check my denominators. I had variables. Is x allowed to be 3? Well, yeah, x is allowed to be 3. The only problem here would be that x cannot equal 2, which is not my solution anyway, so I'm good to go. All right, now let's transition this to make it a little bit more challenging. Take a look at 36. This is where we're going to put what we learned about simplifying rational expressions together with now fraction busters. All of a sudden here, we've got a pretty big equation. We've got p squared plus 2p minus 8 in my denominator. So identifying my least common multiple is going to be a bit of a challenge. All right, when I do that, in order to see that, I've got to break this apart into its 2 groups. I notice it's just p squared, so I can figure out what my factors are by going down to just p and p. And I got to figure out what multiplies to get negative 8 and adds to get 2. Well, that's going to give me a positive 4 and a negative 2. So I've got plus 4 minus 2. So I've got a least common multiple here for my denominator that is 2 groups, p minus 2 and p plus 4. Can I simplify that down at all before I go anywhere else? Oh, hey, yeah, look at that. Notice what I have up top here. I have a p plus 4 up top. That means I can cancel these out. They can both cancel before I go ahead and go with fraction busters. That way I don't have to worry about the p plus 4. Now I only have to worry about getting rid of that p minus 2, and we'll do exactly what we did in the last problem, which is to multiply by p minus 2 everywhere. All right, these will cancel, and this whole thing becomes 1. All right, all that went down to 1, but over here I've got 3 times p and 3 times negative 2, giving me 3p minus 6 equals, and over here those canceled, 4. Look at that entire equation, just by applying 2 skills you learned, simplifying rational expressions and fraction busters, you took that entire equation and you boiled it down to just this little tiny equation, 1 plus 3p minus 6 equals 4, which I can solve. All right, I know that that is 3p minus 5 equals 4. Move that 5 to the other side, and I find that 3p equals 9, and divide by 3, I find that p equals 3. Now, big question, is p allowed to be 3? Yeah. Well, let's take a look at our denominators in this problem. P, oops, that's a b. P could not be negative 4, and it could not be 2, all right, from our groups that are in the denominator. So 3 is allowed. We're good to go. P equals 3 is our solution. I want you to try one. See what happens here in this one here. This one's not in the book. But go ahead and write this one down and pause the video. All right, pausing the video. If you're coming back on now, hopefully you solved it. If you didn't solve it, pause the video and solve it. All right, let's see how you did. Let me start off by, let's simplify some rational expressions here. Let's deal with this mess in front of us. All right, when we simplify rational expressions, let's first start by factoring. Up top here, I've got 2 groups. All right, I know it's just x squared, so it's going to go down to just x and x. And I notice it's a difference of squares. This is a perfect square number. Square root of 25 is 5. Difference of squares means 2 different signs. So I'm going to have x plus 5, x minus 5. All right, so that was a difference of squares. This one down here is actually a perfect square trinomial. Once again, I know it's just x squared, so it's going down to x and x. But again, the square root of 25 is 5. And 5 times x is 5x, double it is 10x. It's a perfect square trinomial. Goes down to x plus 5, x plus 5. Minus over here, I've got 4x, nothing to simplify there. But on the bottom, pull out a GCF. 2 times x plus 5, there we go, equals 1. Now let's start to cancel some things. I notice x plus 5 will eliminate each other there. All right. I notice 2 goes into 4 twice. Now what else do I need to get rid of here? I need to get rid of that x plus 5 on the bottom. So fraction busters tells me that I can go x plus 5 across this whole board here. That is a 5 there. And x plus 5 here. All right, and now my x plus 5s will cancel there, and nothing to cancel there. And I've got what's left is x minus 5. Over here I've got 2x, it's a negative 2x, all right, equals, over on this side I've got x plus 5. Now let's simplify this and keep going. All right, if I do that, I find, let's see what we got here. On the left side, I find I've got negative x minus 5 equals x plus 5. All right, and then let's go ahead, let's add x to both sides. And I'll subtract 5 at the same time. Find that negative 10 equals 2x, divide by 2. I find that x equals, in this case, negative 5. All right, so x equals negative 5. Let's double check for a second. Is that allowed? All right, notice what happens here. If I've got in my denominator here x plus 5, that was what was in my denominator the entire time, that means that x cannot equal negative 5. Well, if that is the only value that will make this true, that's also the only value that when I plug it into the original equation, it will make all my denominators 0. I can't have a denominator that's 0, which means that this will never be true. Even though I found a value that potentially makes it work, that value when plugged back in will actually get you an impossible number. It'll get you something in the denominator. So I actually can't conclude that x equals -5 here. I need to actually come back at this point and I need to conclude that x equals null. There's no value that will make this equation true.